Welcome students. Today we are going to see some more important things with chapters number 2, that is solutions. So back to our 12th chemistry and chapter number 2, that is solutions. And in today's lecture I am going to take division. We have already studied what are solutions, then we have seen certain qualitative properties. We have also seen the deleted or the non-evaluative syllabus or the portion for the year 2020-21, and we have seen certain problems, certain derivations and certain applications of it. In today's lecture, I will be taking some sort of revision for you all so that you all will know. See, question is, if you have a question, like rewrite the relationship between relative lowering of vapor pressure and molar mass of non-volatile solute. So it tells you about, see now, derive the relationship between relative lowering of vapor pressure and molar mass of non-volatile solute. So such types of derivations are asked. It may come as a 2-mark question or as a 3-mark question. According to the weightage, you have to answer it. Now pay attention here. If N1, comma, you can say W1, comma, M1 be the number of moles, comma, molar mass, you can say molar mass, you can just say mass, comma, molar mass of solvent and N2, comma, W2, comma, N2 be the number of moles, comma, mass, comma, molar mass of, since 1 represents solvent, so 2 will represent solute. Now you all know, in previous video or in previous lecture also we have seen that number of moles N1 is equal to W1 upon M1 and we have N2 which is equal to W2 upon M2. Now you all know that X2 which is equal to N2 upon M1 plus N2. So just dividing it or putting the values we get N2, which means W2 upon M2 divided by W1 upon M1 plus W2 upon M2. So when you see this, okay, one important thing you should know that if the solution is very dilute solution, if you have a dilute solution, in this case N2 in the denominator, that is M1 plus N2, this is approximately equal to M1. Okay, so we have now X2 is equal to, you can say X2 is thus equal to W2 upon M2 divided by W1 upon M1. Okay, now See properly. You all know that delta P divided by P1 naught, which is equal to N2 upon N1. Okay, so delta P divided by P1 naught, but you all know over here, this value will be how much? N2 upon N1. So H2, which is equal to N2 upon N1. Okay, clear? So this is equal to W2. N2 means what? W2 upon M2 divided by, okay, divided by W1 upon M1. So just substituting these values, we get W2 into M1 divided by W1 into M2. So such type of derivations, they are usually asked for 2 or 3 marks. So frequently asked questions for board, but for your entrance exam, or if you have an MCQ type of question, for this type of question you should know that delta P divided by P1 naught, which is equal to N2 divided by N1, so which is equal to this W2 into M1 divided by W1 into M2. So this is important and you should know it. Now next we'll take one problem. Just write down the problem. I'll write on the board for you. The problem is the vapor pressure of pure benzene. I'll write in short, the vapor pressure of pure benzene is given as 640 mmHg. Full stop. If 2.175 into 10 raised to minus 3 kg of non-volatile solute is added to 39 grams of benzene, comma, the vapor pressure of solution becomes 600 ml of Hg. Full stop. Calculate the molar mass of solute. This is provided to you for board exam, they will give you, for entrance exam you should know it. That is carbon, mass is 12 and hydrogen is 1. Okay. So now we'll read the problem properly, read the problem so that you know what all is given to you. See now, the vapor pressure of pure benzene is 640 mm of Hg. So vapor pressure of pure benzene is how much? 640 mm of Hg. If 2.175 into 10 raised to minus 3 kg of non-volatile solute is added to 39 gram of benzene. Okay, how much solute is added? This much weight of solute is given to you, and the weight of solute is how much? 2.175 into 10 raised to minus 3 kg of non-volatile solute is added to 39 gram of benzene. The vapor pressure of solution, it becomes 600 mm of Hg. Now this final vapor pressure is also given. You have to calculate molar mass of solute. So what you have to calculate here? Such type of questions frequently asked in board. So calculate the molar mass of solute. Molar mass of carbon is given to you, that is 12, and hydrogen is 1. See now. Now let's go. First thing you should know about benzene. I hope you all know the structure of benzene and the molecular formula, that is C6H6. Okay, C6H6. So molar mass of benzene will be how much? So molar mass of benzene will be 78 into 10 raised to minus 3 kg. Okay. Since now you all know this, we have already discussed this. Since P1 naught minus P divided by P1 naught, which is equal to W2 upon M2, W2 upon M2 into M1 divided by W1. Okay. So now P1 naught, always remember naught, this notation we have already discussed this during the lectures, but I'll just repeat it again. Naught, this notation is for pure. Okay. And what is the value given for pure compound? That is 640 minus 600 divided by 640. Okay. See what is 640? Again I'll read the problem for you all so that you all will understand it. The vapor pressure of pure benzene is 640 mm of Hg. So 640 mm of Hg is vapor pressure of pure benzene. Okay. The vapor pressure of pure benzene is 640 mm of Hg if 2.175 into 10 raised to minus 3 kg of non-volatile solute is added to it. Okay, this is the mass of solute which is provided to you. Is added to 39 grams of benzene. The vapor pressure of solution, it becomes 600 mm of Hg. So vapor pressure of solution, that is P, is 600 mm of Hg. Now you have to calculate the value. So W2, that is mass of benzene, is also given 2.175 into 10 raised to minus 3. Now divided by M2. M2 is that is also, you can say that M2 you have to calculate, and W2 is given to you, that is mass. W1, that is mass of benzene, which is 39 into 10 raised to minus 3, and M2 you have to find out, and M1, that is molar mass of benzene. Molar mass of benzene is 78 into 10 raised to minus 3. 78 into 10 raised to minus 3. Now this cross multiply, this cancellation. So it will be, let's say 40 divided by 640, which is equal to, when you multiply this, you have 169.65 divided by 39. This into 10 raised to minus 3. And this is M2. So this answer it. So you all know this is 40. Okay. So that will be 1 divided by 16 is equal to 169.65 into 10 raised to minus 3 divided by 39 into M2. So just cross multiply, 39 into M2 goes over here, and this value, that is 169.65 into 10 raised to minus 3, you multiply it by 16. So the value comes out, and then you divide it. So when you go for cross multiplication, when you go for cross multiplication, you will get M2, which is equal to 2714.4 divided by 39, and as usual into 10 raised to minus 3. So the answer comes out to be 69.6 into 10 raised to minus 3 kg, and when you divide this by 10 raised to minus 3, so you get 69.6 kg, you can say gram. Okay, so the answer is in gram per mole. Very simple over here. What you all should know over here is, this is very simple, that you should know just one formula, that is P1 naught minus P divided by P1 naught is equal to W2 upon M1 into W1 upon M2. So this you should know. Last one more problem will take today's lecture. One more problem, that is calculate molarity and molarity of 63%, I'm sorry, 6.3% of solution of nitric acid having density 1.04 gram per cm3. Here hydrogen is equal to 1, nitrogen we all know 14, oxygen is 16. So calculate the molarity and molality of 6.3% of solution of nitric acid. Now 6.3%. Now see, mass of solute is given to you. See, because mass of gram. If 6.3 gram of solute is present, how much solvent will be present? So mass of solvent, since it is 100%, because we are being provided in percentage, so it is in 100%. So 100 minus 6.3. So here the answer comes out to be 93.7 grams. So this is mass of the solvent. Now you all know molality of HNO3, that is M. So the formula is mass of HNO3 divided by molar mass of HNO3 into mass of solvent. So here, just substituting the values we get. Now see over here, we have mass of HNO3 which is provided, that is 6.3 into 10 raised to minus 3, that is kg. Divided by molar mass of HNO3 is 63 into 10 raised to minus 3, which is again in kg per mole. And mass of solvent we have just calculated, that is 93.7, but this is in grams. Converting into kg, we have into 10 raised to minus 3 kg. So this entire is divided. So here the answer, it comes out to be 1.067 mole per kg. Let's go to the another part, that is we have to find molarity. So we have volume of solution, because we have been provided with density. You all know density is equal to mass upon volume. So volume is equal to mass upon density. So mass of solution divided by the density of solution. Okay. So mass of solution, you all know it was in percentage, means it was 100%. And divided by density which is provided to you, and that is 1.04. So here the answer, it comes out to be 96.15 cm3. So when you convert it to dm cube, you have 96.15 into 10 raised to minus 3 dm cube. Now you have to go for the molarity. Now when you have to go for the molarity, you should know the formula of molarity. So molarity of HNO3 and formula of molarity, that is capital M, that is equal to mass of solute in kg, which is provided, divided by molar mass of solute into volume of solution in dm cube. So now see, so this is equal to 6.3 into 10 raised to minus 3 kg divided by molar mass of solute is a molar mass of, you can say, HNO3, which nitric acid, which was 63 into 10 raised to minus 3. Okay, so this is kg per mole. And volume of solution just now we calculated, that is 96.15 into 10 raised to minus 3 dm cube. So when you calculate all this, the answer comes out to be 1.04 mole per dm cube. So molarity, molality and all these concepts, they are very important for your board exam also, and they are also important with respect to your entrance exam. See that you all prepare this chapter properly, go through all the solved problems. Please try to solve the exercise which is given at the back of the textbook. Study properly. All the best for your papers.